Hello everyone, this is Sandhya. I'm a data science enthusiast at Alma Beta. Today I'm going to talk about the Capstone project that is related to machine learning. The name of the project is Unsupervised Machine Learning, Netflix movies and TV shows clustering. So this dataset consists of TV shows and movies available on Netflix as of 2019. The dataset is collected from Flexible, which is a third party Netflix search engine. In 2018, they released an interesting report which shows that the number of TV shows on Netflix has nearly tripled since 2010. The streaming services number of movies has decreased by more than 2000 titles since 2010, while its number of TV shows has nearly tripled. It will be interesting to explore what all other insights can be obtained from the same dataset. Integrating this dataset with other external datasets such as an IMDb ratings, Rotten Tomatoes can also provide many interesting findings. So let's move to the problem statement. So first let's know about Netflix. So Netflix is one of the world's leading entertainment service with over 260 million paid membership in over 190 countries enjoying TV series, films and games across a wide variety of genres and languages. Netflix is the most subscribed video on demand streaming media service with 260.28 million paid memberships in more than 190 countries as of January 2024. So, it is crucial that they effectively cluster the shows that are hosted on their platform in order to enhance the user experience, thereby preventing subscriber churn. So, what we will do in this project, we will be able to understand the shows that are similar to and different from one another by creating clusters which may be leveraged to offer the consumers personalized show suggestions depending on their preferences. The goal of this project is to classify the Netflix shows into certain clusters such that the shows within a cluster are similar to each other and the shows in different clusters are dissimilar to each other. Now let's talk about project goals. In this project, what we have to do, the first is the exploratory data analysis, then understanding what type content is available in different countries. If Netflix has been increasingly focusing on TV rather than movie in recent years, clustering similar content by matching text based features. Then dataset description is given, like show underscore id is equal to the unique id for every movie and TV show. Type is identifier, a movie or TV show. Title of the TV. Director of the movie. Cast means actors. Country where the movie was produced. Date added. Then release year. Rating. Duration. Listed in means genre. And at last description, the summary description. First, what we did, we imported the important libraries: pandas, numpy, matplotlib, seaborn, date time warnings, right? So these are the important libraries we have imported. The next thing we did, loading the data set, right? Df is equal to pd dot read csv, then the copy the path and then load the data set. Then third is the reading data set. Next, overview of dataset. In this, the overview of dataset means in this we can retrieve the first few rows or first 5 rows of the data frame to inspect its structure and contents with the help of df.head. Next, retrieve the dimensions. Dimension means to know the number of rows and column in the data frame with the code df.shape. Then data cleaning. As we know, data cleaning means the process of identifying, correcting, and removing the errors, inconsistencies, and inaccuracies in a data set to improve its quality, reliability, and usability for analysis or other process. This process involves such as removing the duplicates. We will do removing the duplicates and how to handle the missing values and resolving discrepancies to ensure that the data is accurate, complete, and consistent. Basically, the goal of data cleaning is to prepare the data set for further analysis or application while minimizing the risk of errors or biases that could lead to incorrect conclusions or decisions. So, first, what we did check for duplicate rows and data frame. So, no duplicate rows found. Now we are checking for the missing values, and no missing values we found in the data set. Right. Then checking the unique values in each attribute of the data set. Right. The number of title, then directors, then cast name, countries, then date added, how many. Right. Then we did handling the missing values. As I already told you, these are the part of data cleaning process, how to handle the missing values. Then country and listed in genres, right? Then there are different kind of genres like dramas, comedies, documentaries, action and adventure, crime, kids TV. Okay, so basically there are some movies or TV shows that were filmed in multiple countries. They have multiple genres associated with it. To simplify the analysis, let's consider only the primary country where the respective TV show or movie was filmed. And let's consider only the primary genre of the respective movie and TV show. So we are choosing the primary country and primary genre to simplify the analysis with this code. Yeah, next we are doing typecasting. In this, we are typecasting the duration from string to integer. We are splitting the duration column and changing the data type to integer, right? And then movie length in minutes we have changed. And so we have successfully converted the data type of duration column to integer. Then we did typecasting. In typecasting, date added from string to date time. So it will help in the further process. So typecasting, we did date added from string to date time, right? The shows were added on Netflix between 1st January 2008 and 16th of January 2021. So, but we did first and last date on which a show was added on Netflix with df.date added minimum to df.added max. It shows that the shows were added on Netflix between 1st of January 2008 and 16th of January 2021. Now we move to other rating. In age rating for shows in the data set, then highest number of shows on Netflix are rated by TVMA followed by TV 14 and TVPG. This graph is showing the highest number of shows on Netflix are rated by this TVMA, then followed by TV 14 and then TVPG. Now age rating. Now we are changing the values in the rating column. So suppose TVMAs, we are changing TVMA to adults or adults. Okay. So we will able to understand. Yeah, now we have changed. So but the graph is telling us that most shows on Netflix are produced for adult audience, followed by the young adults, then older kids, and Netflix has the least number of shows that are specifically produced for teenagers than the other group. Second, after the data cleaning, that is the exploratory data analysis. So what is exploratory data analysis, or ED? It's an approach to analyze data set, to summarize their main characteristics, to employing the visual methods. Its primary goal basically is to gain insight into the data, identifying the patterns, trends, and anomalies and relationship between variables. Actually, ED helps us to understand the underlying structure of the data and formulate the further investigation. So we did first univariate analysis. Univariate means which involve a single variable at a time to understand its distribution, central tendency, dispersion, and other summary statics. So first what we did, number of movies and TV shows in the data set. So this pie chart is showing that movies is 69.14% and TV shows 30.86. It means there are more movies than the TV shows in the data set. Second univariate analysis is top 10 directors in the data set. So this horizontal bar graph is showing Roll Campos and John Suited together have directed 18 movies, TV shows higher than anyone in the data set. With the help of this bar graph, third, top 10 countries with the highest number of movies and TV shows. So, United States, highest number of movies and TV shows, followed by India, and then closely followed by the United Kingdom. Then percentage share of movies and TV shows by top 3 country. We got it 56%, and then percentage share of top 10 78. So the insight is the top 3 countries collectively contribute to approximate 57% of all movies and TV shows within the data set. And while this proportion escalate to around 78% for the top 10 countries. Now we are visualizing the year in which the movie and TV show was released. Okay. So this histogram illustrates the distribution of movie and TV show release years. So with a noticeable increase in the number of releases after 2000. As you can see, yeah, after 2000, the increase in the number of releases. And these peak indicate the period of higher production or favored eras, while gaps suggest shift in the content creation or data set coverage. By understanding these patterns and strategic content planning and audience targeting for platforms like Netflix. Now, what are the top 10 genres? Yeah, by looking at this bar graph, horizontal bar, we can see the first is drama, followed by the comedies, then documentaries, and action and adventure. So, this visualization depict the top 10 genres based on their frequency within the dataset. Dramas, as I already told you, dramas emerge as the most prevalent genre, closely followed by the comedies and documentary. As we can see, comedies and documentaries. And collectively, these three genres approximately constitute 41% of all movies and TV shows, and the dominance of these genre become even more pronounced among the, if we are talking about the share of top 10 genre, it become 82% of the total content. This highlights a clear preference for these genres among viewers, underscoring their significance in content consumption trends. Next, we are talking about number of shows on Netflix for different age group. This is also the horizontal bar graph. As we can see, the majority of the shows on Netflix are catered to the needs of adult and young adult population. Now move to the bivariate analysis. Bivariate, it focus on relationship between two variables. Right. So in the first one, we are talking about the number of movie and TV shows added over the years. Right. With the help of this graph, Over the years, Netflix has maintained a consistent emphasis on expanding its library of shows on its platform, while there was a decline in the number of movies added in 2020, as we can see. A similar trend was not observed in the addition of TV shows during the same period. This might signal that Netflix is increasingly concentrating more on TV series rather than the movies, as we can see the gap. Second, bivariate analysis about the seasons in each TV show. As we can see, seasons in each TV show, right? So the TV series in the dataset it range up to 16 seasons, as we can see, 16 seasons. Yet the majority of them consist of only one season. This observation could imply that most TV shows are relatively new with potential seasons in the future. Additionally, there are very few TV shows with more than 8 seasons, right? Then we are talking about the length of movie analysis, means the duration, the distribution. The duration of the movie typically spans from 3 minutes to 312 minutes, exhibiting an almost the normal distribution. Then average movie length we are talking about over the years. So Netflix offers a diverse selection of movies spanning from classical dating back to the 1942, right, to contemporary releases in films from 1940s to have relatively shorter duration, as we can see, right. While those in 1960s they have the longest average lengths. Notably, there has been a consistent decrease in the duration of the movie's length since the 2000. Next is top 10 genres for the movies. What are the top 10 genres for the movies? These are dramas, comedies, documentaries, right? And top 10 genres for the TV shows, the international, crime, and kids genres. They are among the most sought after categories for TV shows on Netflix, resonating strongly with viewers across diverse demographics, from gripping international dramas to thrilling crime series and engaging content tailored for younger audiences. These genres offers a captivating array of viewing options that cater to a wide spectrum of preferences and interest on the streaming platform. Then top 10 movie directors. Right? Roll Campos and John Sutter hold the record for co-directing a remarkable total of 18 movies together. Right? It's close to that. Surpassing any other duo in this respect. So following closely behind with the Marcus J and Kathy Garcia Molina. Top 10 show directors. TV show directors. Alastair, followed by Ken. They are marking the highest count among all the directors. Then top actors for the movies, right? Samuel West, right? Samuel West boasts an impressive presence in the 10 movies and securing the top spot, closely followed by the Jeff, who has graced the screen in 7 films. Then top actress for TV shows, right? David appeared in almost 13 TV shows, followed by Michaela, Jamie, Anne, Dante, and Eric Peterson were the 4 TV shows. Now, now we are building a word cloud for the movie descriptions. Right? This is the word cloud. So the collection of significant keywords commonly found in the Netflix TV show descriptions, ideal for generating a word cloud. These are including life, as we can see, family, new, love, young, world, group, death, man, women, mother, son, girl, documentary, and secret. Secret. The next is data pre-processing. Basically, data pre-processing, it's a fundamental step in data analysis and machine learning pipelines. It involves transforming raw data into a clean, organized, and suitable format for further analysis or modeling. The primary object of data pre-processing to enhance data quality, resolve inconsistencies, reduce noise, and prepare the data for analysis and modeling tasks. These are the modeling approach. We have to select the attributes based on which we want to cluster the shows. Then text pre-processing, right? In text pre-processing, we will remove all the non-ASCII characters, right? Stop words, punctuation marks. We will convert all textual data to lowercase. Then lemmatization, right? Then tokenization, then word vectorization, dimensionality reduction, and then we will use different algorithms. Okay, so we will cluster the shows on Netflix based on these attributes: director, cast, country, genres, and descriptions. First, we are using the original dataset for clustering, right? Since it doesn't require any missing values. Now we are combining the clusters because we need director, cast, country listed in our genres and description. So finally, we have successfully added all the necessary data into a single column. Now we are removing non-ASCII characters. So what are these ASCII characters? It's based on the American Standard Code for Information Interchange. Okay. So non-ASCII characters, they are basically represented using different encoding schemes such as UTF, Unicode Transformation Format 8-bit. Right. They support a wider range of characters compared to ASCII encoding basically. Right. So because we already talk about these characters, right? Like punctuation marks, articles. Okay, so we have successfully removed all the non-ASCII characters. Now we are removing stopwords. Basically, stopwords, they are commonly used in the natural language that are often filtered out or ignored during the text processing and analysis because typically they do not carry any significant meaning or context. Because basically, stopwords, they are pronoun, right? Punctuation, they are pronoun conjunctions. Okay, so we have successfully removed all the stopwords and converted the corpus to the lowercase. Now we are removing the punctuation. Right. Next process is the lemmatization. So lemmatization, basically it's a pre-processing step in the natural language processing to normalize text data. Basically what lemmatization does, it helps us to reduce words to their base or directory form, the dictionary form, which we call the lemmas. And this can improve the performance of machine learning models by reducing the vocabulary size and capturing the essential meaning of the words. And then we did tokenization. Tokenization is basically breaking down a sequence of text into smaller units. We call them tokens, and these tokens can be words, right? Suppose we are breaking down words, we are breaking down phrases, symbols, or some meaningful elements. Then vectorization means converting the data into numerical vectors or arrays, and then enabling the mathematical operation and analysis. Basically it's a fundamental step in preparing data for machine learning algorithms that typically require numerical input. So we did tokenizations here. Then dimensionality reduction using the PCA means using the principal component analysis to reduce the dimensionality of data, right? Basically, what this graph says, we find that 100% of the variance is explained by about 70 7,500 components, and also more than 80% that is explained just by 4,000 components. So, to simplify the model and reduce dimensionality, we can take the top 4,000 components, which will still be able to capture more than 80% of the variance. Right. So, now we are reducing the dimension to 4,000 using principal component analysis. And then we have successfully reduced the dimensionality of the data using principal component analysis. Next is cluster implementation, k-means clustering. We are building the clusters using the k-means clustering algorithm. And in this visualization, the elbow curve and slot is scored to decide on the optimal number of clusters for k-means clustering algorithms. Right. So the sum of square distance between each point and centroid in clusters decreases with the increase in the number of clusters, as you can see. Right. Then the highest Lotus score is obtained for six cluster and building six cluster using the k-means clustering algorithms. This is all the process of clustering. So after successfully building six cluster using the k-means, and then at last we are building world clouds for different clusters. Right. So first world cloud, it has some keywords like life, new, family, friend, save. Second, it has young, wild, mysterious, humanity, life, student. So all of these are the world cloud for different clusters we have made. Now, hierarchical clustering. Basically, what is hierarchical clustering? In this building cluster using the hierarchical clustering algorithm, and we are visualizing the dendrogram, right, to decide on the optimal number of clusters for hierarchical clustering algorithm. So we are building a dendrogram to decide on the number of clusters. This we did. So at a distance of 3.8, at a distance of 3.8 units, we can see 12 clusters we can build using this clustering hierarchical clustering algorithm. So building 12 clusters using the hierarchical clustering algorithm. Right. We did all of these things. And number of movies and TV shows in each cluster. Right. Now we successfully built 12 cluster using the hierarchical clustering algorithm. And now we are building world clouds for different clusters. Right. These are the world clouds for different clusters. So total 5, 7. We made all the 12 clusters. Yeah. Now moving towards the content based recommender system. So what is content based recommender system? In this we can build a simple content based recommender system based on the similarity of the shows. It's a simple, like if a person has watched a show on Netflix, so the recommender system must be able to recommend a list of similar shows that he or she likes. So to get the similarity score of the shows, we can use cosine similarity, the similarity between two vectors, that is calculated by taking the dot product of the two vectors and dividing it by the magnitude value as shown in the equation below. Right. So we can simply say that the score of the two vectors, right, this increases as the angle between them decreases. It is this, right. And then we will develop function to get the recommendation. So we get 10 recommendation for a show. Okay, suppose we want to recommend a man called God. Okay, suppose I want to recommend someone a man called God. So there will be some recommendation like if you like A Man Called God, so you may also enjoy these movies, right? So these are the second is the recommendation for Stranger Things. Like it will come like if you like Stranger Things, so you may also enjoy these, right? So basically we have created, right? If yeah, if we're recommending something, so if it is not available on Netflix, so it will show invalid entry. So now move to the conclusion. So basically what we did in this project, so I worked on a text clustering problem wherein I had to classify the group, or I had to classify the Netflix shows into certain clusters such that the shows within a cluster are similar to each other and the shows in different clusters are dissimilar to each other. This data set contained about 7787 records and 11 attributes. So we begin by dealing with the data set's missing values, then doing the exploratory data analysis, that is ADM. So it was found that Netflix hosts more movies than TV shows on its platform, and the total number of shows added on Netflix is growing exponentially, right? So also majority of the shows were produced in the United States, and the majority of the shows were created for the adults and young adults age group. It was decided to cluster the data on the attributes like director, cast, country, genre, and description. The values in these attributes were tokenized, pre-processed, and then vectorized using TF-IDF vectorizer. Through this vectorization, I have created a total of 20,000 attributes. We use principal component analysis PCA to handle the curse of dimensionality. 4,000 components were able to capture more than 80% of variance, and hence the number of components were restricted to 4,000. Then we first built clusters using the k-means clustering algorithm, and the optimal number of clusters came out to be 6. This was obtained through the elbow method and Slotte score analysis. Then clusters were built using the hierarchical clustering algorithm, and the optimal number of clusters came out to be 12. This was obtained after visualizing the dendrogram. A content based recommender system was built using the similarity matrix obtained after using cosine similarity. This recommender system will make 10 recommendations to the user based on the type of show they watched. So, these were the insights from this project. Thank you so much for having me. Thank you so much.